Rock aggregate for concrete was quarried from the mountain. An old mountain going into a new concrete mountain. 1 million cubic yards of concrete. More than 1 million cubic yards of aggregate. In 6-inch pieces. In 3-inch. 1.5 inch. And in 3/4-inch pieces. And also coming out as sand, part of a mountain ground down to sand. All at an average of 325 tons an hour. Crushed rock, sand, sweat, and cement. A dam was being manufactured. Rock, sand, water, and cement. 8 cubic yards per bucket. Karadj Dam was fast becoming a reality and a construction showpiece for Iran. High overhead cableways spanned the gorge, anchored between great steel towers. Working on the run, along a berm, a level place, cut from the canyon wall, head towers and cables are the arms and sinews of modern dam building. They put the concrete where it's wanted. They came to the job piece by piece, from over the sea, through the canyons and over the ridges of the Elburz Range. The transfer cars, shuttling back and forth from the mixing plant, serve the high lines, and the high lines serve the men on the dam. It's hook on and highball. A dam is being built. Eight cubic yards of concrete, 33,000 pounds, bucket after bucket. One of the world's highest dams, 1,285 feet long at its final roadway crest, and eventually containing 1 million cubic yards of concrete. A new and productive monument for Iran, growing in 8-yard strides, coming in on cables, thick as the arm of Xerxes. Growing to a final height, 590 feet above the riverbed, 98 feet thick at the base, 27 feet at the crest. Curving both outward and upward for added strength and substantial savings in concrete volume. As tough a job in as tough a location as dam builders have tackled anywhere. The men on the cars challenged the men on the vibrators. The men of Iran, 3,200 strong, supervised by a nucleus of long experienced MK dam builders, were shaping the progress of their homeland. Water storage for their capital city. Concrete was placed in maximum lifts of 6.5 feet. The language of construction is universal. To an engineer, it's place the concrete. But to an old construction man, an old hard hat, it's pour the mud. Concrete may be mud to some, but to the laboratory technician, it's curing time, tensile and compressive strengths. The material is strong when it's born, and concrete gains in strength with age. In the laboratory of Harza Engineering Company, project designer and inspector, samples are cured under controlled conditions for 7, 14, or 28 days. Then, they're purposely smashed to rubble. Compressive testing measures the force that samples can withstand. The laboratory is the proof of the mix plant. Just how good is the concrete? It has to be good, good far beyond design requirement. All samples are broken in order to measure compressive strength. Around the clock and around the calendar, the job is more than to make and pour concrete. We're building a dam, despite the variables of nature. So cool the mass in summer, heat it in the winter, and the blocks keep going up and up and up. But it wasn't all a high-line show. A stiff-legged derrick had to serve those random areas beyond the reach of the big cableways, the outfield areas of the dam's long arch. Under the skillful direction of M.K. dam builders, the proud sons of Iran were fast becoming hard hats. Green cut the pour for yet another pour. Roughen the surface for the next lift. Raise those forms. Up. Again. 3. 4. Pull. Again. Some jobs are still best done by hand. Forms have to be set right on the nose. Once the reservoir fills and sends water rushing down the steep spillway, cut into the sheer face of the canyon, the people of Iran can well celebrate a big job well done. Assured water storage for all their needs. But there'd be added reasons too. Tucked close to the downstream toe of the dam is a powerhouse, a new source of energy. Ultimately, 110,000 kilowatts of power to satisfy Tehran's growing need for electricity. The initial 2 turbines and all control gear would be furnished and installed by MK. Provision is also made for an additional 3rd generating unit. Dam construction may start with roads, but powerhouses start in a way with a man and a saw. Lumber brought from far away, as was done for Darius at Persepolis. Lumber, not for a palace roof, but forms for a powerhouse, for the draft tubes, for a turbine pit. The job has always been the same, man working for his own betterment.